Hello, my name is Annalisa Baronetto and welcome to the presentation of our study. Auscultation is a standard non-invasive medical practice consisting of listening to body sounds for typically a few minutes. Unlike lung and heart sounds, the analysis of bowel sounds remains an open challenge because of the random sparse occurrence and the very low amplitude. It is then difficult to extract meaningful digestion-related markers from clinical short-time auscultation, as it may capture only a few or non-bowel sounds. To overcome the limitations, we developed a novel wearable device called GastroDigital Shirt. Our prototype consists of a smart t-shirt embedding 8 miniaturized microphones connected to an external low-power wearable computer. The fabric is made of elastan, which makes the t-shirt highly stretchable and comfortable. The GastroDigital Shirt is available in different sizes to fit the largest population possible. For our study, we recruited 4 participants with no prior gastrointestinal diseases. Bowel sounds were recorded before and after meals, with the participants keeping a quiet position as well as during exercises to record the typical motion artifacts. In total, we collected 15.5 hours of audio for the analysis. The dataset was labeled by 2 independent trained raters. The annotation marked in total over 3,000 bowel sounds, with a substantial agreement between the 2 raters. The dendrogram showed the presence of 4 main bowel sounds clusters, so we decided to apply the hierarchical agglomerative clustering with a 4-cluster configuration. The clustering was later applied to each participant separately. The number of bowel sounds per cluster is not balanced across the participants. In particular, most of the instances belong to the first 2 clusters. The difference across the participants can be mainly due to the natural inter-individual variations of the digestive processes. Another secondary cause could be the suboptimal fitting of the GastroDigital Shirt, which caused random detachment of the sensors from the skin. We analyzed the cluster similarity by computing the inter-cluster distance. Despite some clusters extracted from different datasets are similar, not all clusters stay consistent. The high variability of bowel sounds clusters might be due to the noise contamination of data, which was collected in a less constrained setting. In conclusion, we presented a novel wearable device suitable for long-term digestion monitoring. With our prototype, we could identify 4 bowel sound patterns, which can be related to non-bowel sounds types. We investigated bowel sound variability and their temporal evolution along different digestion phases, which was not investigated so far. For further information on this study, do not hesitate to contact me. Thank you for your attention, and I wish you a great time at this year's ESWeek.